Hello, Kasia.
Hello, Adam.
So I would like to ask you a few questions. I know that you are in the neuroscience field for some time, and I would like to ask you for your work because I'm aware that there's a lot of cool things happening in universities and in different kind of like institutes all over the world, but not very often people have a chance to actually see and hear in simple words what is happening inside these hidden laboratories, what are the outcomes, and I'm pretty sure that what you're doing in Polish SWPS University is pretty significant and pretty interesting for more users. So can you kind of like introduce yourself to us?
Yes, hello, Adam. Thank you for having me. I'm Kasia Wisiecka. I'm a PhD student in SWPS University and Polish-Japanese Academy of Technological Processing. Actually, my thesis project is about collaboration and discovering some processes between this collaboration, such as joint attention or synchronization, HRV synchronization, and elaboration of some solutions such as gaze visualizations that can enhance remote or face-to-face collaboration. But today
Actually, I was a part of this test with the oculid glasses, right? So
how did you feel? Actually, you can tell something about this.
Yeah, I was pretty comfortable. I was set it up with all the kind of like eye tracking glasses, and I was asked to do the Hanoi Towers along with my friend, so that was pretty okay. I think I still have to fill in the form that I forgot to send it to you, but later on.
Adam, no.
We're gonna talk about it later on. Moving back to the main topic. so your work at SWPS.
Yes, and I work in eye tracking research center. My supervisors are Krzysztof Kreitz and Izabela Kreitz, and also Kazimierz Zieliński. And today I would like to tell you something about my actually first bigger study, because I like it very much, and this was my first experience, so big experience with eye trackers, and we got really nice results. I really like to talk about this, so I decided to actually present it today.
Awesome. So please go ahead, dive in.
Adam, can I share my screen?
Yeah, sure. I think
Thank
you have the option. Yeah, we can see it.
Cool. So I don't know, can I start, or do you have like...
Yeah, maybe you can just tell us a bit about the phase in your own words. Maybe you just go ahead and
okay.
Go ahead, do it your way.
So first of all, I would tell something about backgrounds and theoretical background and recent related works, to understand how these processes work. The main topic is dynamic of emotional facial expression recognition in individuals with social anxiety. So actually, as social animals, we have learned how to rapidly and efficiently decode emotional information from facial expressions. Even one or two eye movements can be enough to recognize a face, or not many more fixation actually are needed to recognize emotions. Emotion is always some kind of information which is passed to us, and we need to learn how to catch it and interpret. Importantly, visual patterns of emotion recognition depends on individual differences. Cognitive models, for example, of social phobia, state that there are biases of social threat cue processing that underline social anxiety. And eye tracking, the most important word here. So eye tracking enable us to observe visual tendencies during emotional facial recognition and among people with several disorders. In the picture here, we can see registered patterns of visual scanning of the emotional expressions in the group of people with social anxiety disorder compared to controls. Correlate indicates typical tendencies which occurs when people look on the other person's face. Here's like the eye contact and little triangle, which should appear from fixations. Fixations are these little dots, and saccades. Saccades are lines. On the other hand, the socially anxious group hyperscan the face. It might lead to some confusion and wrong interpretation of, for example, other person's state of mind, and also cause bigger fear and make this circle of social phobia. Understanding of differences between anxious and healthy controls requires research which use visual attention to specific emotions. And it's examined simultaneously and dynamically. For example, study of Toro Alves showed better performance in socially anxious group when stimulus was presented dynamically. However, it was only behavioral study, and there was still a lack of data about physiological response to dynamic appearing emotions in socially anxious group. So we started to think how to catch not only these basic visual tendencies, such as, for example, avoiding eye contact among socially anxious people, but also how to measure lower visual control or withdrawal towards emotions during recognition. Sorry, my dog wants to tell, I think, something, but I will continue. So then we decided to use K coefficient, and it calculates focal and ambient attention. Maybe I will explain it in a few words. So focal and ambient attention, actually modes of visual information processing, change dynamically. At early stages of visual perception, shorter fixation and longer saccades govern initial stimuli exploration. And once a target has been selected, longer fixations are followed by shorter saccades, suggesting a change to this focal processing. And here we can see how the expert, who was more focal, explored the chest to find some flaw, and novice, who was more ambient. So in other words, we can say that focal attention is like indicative of deeper information processing. Adam, can I just take my dog out of my room?
Yeah, sure. You can introduce your dog to us.
Make contact here.
That's perfectly fine. By the way, Kasia is such a science freak that her dog's name is Curie, Maria Skłodowska-Curie, who I'm pretty sure all of you know who is. So let's just give Kasia a moment.
Okay.
Kasia, is that right that your dog name is Maria Skłodowska-Curie?
Yeah.
Okay.
Yes. She's Kitty. She has her best friend Freud. Yeah, they're a really nice couple together.
Cool.
Okay.
Okay, we can continue. So basically, the idea is that people who are kind of like professionals in certain areas are viewing images differently than people who are kind of like novice. As for this example, like doctors who are used to these images were leaving longer fixations and lower saccades, and people who are novice were just kind of like scanning the path, didn't know what to focus on. Is that right?
Yes, but when we are more expertise in some area, we might be even more ambient because we need just a quick look and peripheral visual scanning, and that's all to find some flaw, for example, in the chest. But this is only like example, but this is only to show you that it can tell us about some cognitive processing. So we have here indicator that can tell us that, for example, we need more resources or we are more focused on some topic. Yeah.
Okay.
Okay.
Nice.
And we also chose pupil size as indicator of withdrawal. And the size of the pupil also report about deeper engaging and processing. And that is why we hypothesize that during the time course of this emotion recognition, the pupil dilation combined with the distinction between ambient and focal attention might reveal some group differences in this dynamic processing of social emotional stimuli, right? Because the size of the pupil will change and, for example, will be bigger pupil, and it also can tell us about this deeper processing. Okay, so in simple words, the main goal of this study was to explore the dynamics of recognition during exploration of natural evolving expressions and support cognitive model of social anxiety. When we will look, for example, back here, and we can see these really small dots and log saccades in socially anxiety group. We actually hypothesized that we will catch here more ambient attention among socially anxious group. Okay, so maybe I would tell something about method now.
Yeah.
We had 48 participants, 24 were anxious, and we presented them 18 video clips. We showed them a face which showed natural changing expression from neutral to happy, sad, or angry. We recorded their visual attention by SMI eye tracker 120 hertz. And it was laboratory study, and not only study.
So it was like a video of face changing very slowly from neutral to one of the. Oh yeah.
Yes. Here we can see a procedure. Exactly. So the maximum time of this display was 10 seconds, but actually, as I remember, the mean time of recognition was like 2-3 seconds. So it was really a quick decision to make. And the participants' task was to press a space bar as soon as they recognize the displayed emotion. And next, they chose the emotion they recognized. So that this procedure will look like. And our main results, I will only show you these more important. So I have to go back again to this picture with AOIs, so areas of interest. We had 4 AOIs: forehead, eyes, nose, and mouth, because we would like also to see if, for example, visual attention to some parts of the face is different between groups. But actually, taking a dwell time, we didn't see here any significant results. However, happy faces recognition was faster than angry or sad in both groups. And non-anxious group recognized emotion faster than socially anxious group. So this is important. Remember about this because I have some surprise at the end. So this is like very important result here. And now our eye tracking indices. During early stages of facial expression recognition, all participants exhibited more ambient attention compared to later stages. Yes, so this is like natural recognition. However, in the later stages, before a decision, both groups switched to more focal attention. And socially anxious individuals actively scanned faces for a sign of emotional expressions. And this hyperscanning was reflected by average ambient attention, especially during happiness recognition. So this actually supported our hypothesis. And pupil dilation, also very interesting results. During the emotion decoding process, pupil dilation increased. However, change in pupil dilation was smaller in anxious group, reflecting decreased processing of angry facial signals. And this is also something that we have to remember. And conclusions. We supported actually happiness superiority effect during emotion recognition. So natural control group and also anxious group first recognized happy face faster and with more accuracy. We indicated that the mechanism of this maintenance and withdrawal in socially anxious group is possible to calculate from dynamic eye tracking analysis. And we underlined that this possible, that there is some cognitive cost during the process of recognition in this socially anxious group. So we have to pay attention to it, or maybe develop some attentional training in this group.
How did you calculate it, the cognitive demand based on the pupil?
Yes, based on the pupil, but as you remember, this ambient mode also indicate that they need some more time and have to engage more resources, cognitive resources, to recognize some emotion, especially that is a source of a threat, for example, or is a threat cue. Okay.
Hey, that's pretty interesting. Hey, so does it mean that we could like reverse the process and kind of like detect anxious people, like anxiety in people's heads by presenting them, for instance, this study? Because I assume that you took two groups, the control group and the people with kind of like anxiety, and based on this, you took some outcome of it. So does it mean that if you take a random person and present with the test and see the results, then you will be able to detect kind of like, even kind of like a doctor, a psychologist, tell the people that he or she is struggling with anxiety?
I mean, I think that this is my opinion because I know this research and I actually looked at thousands, I think, scan paths of visual attention, both in socially anxious group and controls. And yeah, I think that it is possible. It could be like a support to diagnose some disorders. Of course, it shouldn't be like the only one indicator of these disorders, but if it would be possible to use like on daily basis, for sure it might help professionals to recognize some problems like cognitive tendencies or visual biases.
Amazing. Cool. And are there any kind of like next further steps with this research? Did you kind of like learn something that you want to extend further on by, I don't know, doing some additional research on some topic, or I don't know?
Yeah,
Like
I thought actually to go in this direction. It is really funny that you told like a second ago. So maybe if it would be possible, for example, to use it eye tracking, I don't know, in the office or during the therapeutic session. It might be some source of information. And actually, I did a study online
Okay. That was
using
not.
using this, but of course there are many directions what to do with these results. I told you something about trainings, for example, how to change this perception of emotions. We had some study with mindfulness training, and we checked these tendencies before and after training. I had also idea to use EEG. So there are many directions what to do next with it. Or compare it to, for example, different groups. We checked also this with group with hearing difficulties. Yeah.
Interesting. Okay, thanks. That answers the question. I've seen that you did similar kind of like research also online. This is what the slide states for. And have you found kind of like similar types of results and similar types of conclusions, outcome from the online, or for instance, probably there were no pupil size as I can imagine.
Yeah, but we can see here very promising results. And remembering about this previous one, I would like to show you that actually we can catch here some basic processes and biases.
Awesome.
So maybe I will tell you something
Please,
more.
go ahead.
We had a little bit different stimuli because we used also a part of the face, like the bottom and top, but also the whole face. We had 23 participants, 11 were anxious. And actually, I didn't expect to hear any differences in accuracy, but actually results reveal some significant difference between group. Here we have many results, but I would like you to focus attention here on happy top face. It's HT. So socially anxious group recognize happiness from top of the face with lower accuracy. So when we remember about these previous results, maybe here on this group, it was something what decreased this accuracy also. Okay, and now recognition time. Also, socially anxious group recognize happy whole face longer than a control group. And when we would take only the whole faces here, the results were the same as in the previous experiment. So in general, anxious group needed more time to recognize emotion. And basic eye tracking indices. So first, fixation count. Anxious group had less fixation on eyes during happiness and sadness recognition, as you can see here. And second, dwell time. Again, when you look on the scale especially, there's longer dwell time on eyes among control group during happiness and anger recognition. But look what happens here during sadness recognition before, and during anger recognition, anxious group spent more time looking at eyes. And probably when we would calculate ambient and focal attention, the results might be comparable to previous one, because on the previous slide we can see that they had like more fixation on eyes than control group during anger recognition. So yeah, so this is like something what is like a base to make more analysis maybe calculate some ambient focal tension. But I'm happy that we have something.
Yeah, I'm also happy to see and to hear that, like using the online approach brings you the same outcome as using the laboratory in this case. Because like obviously for me, since I'm representing the online eye tracking kind of like approach, it means a lot that it can be used for such an amazing research with possible future outcome of kind of like the detecting some anxiety in people and so on and so on. Awesome. Kasia, thank you. Do you have any more slides for us to
No,
to show us?
that's it. I have to go to my dog, I think.
Yeah, maybe. Yeah, it's about time. Okay, thanks a lot for showing us your research, your thesis, and well, if someone, if any of you who's watching this video have any questions to this research or to Kasia, then feel free kind of like to ping us on email, and we're gonna kind of like try to answer the questions. Thanks, Kasia, again, and say hi to your dog, and well, have a nice day, and thank you. Good luck with the continuing the research.
Thank you. Bye.
Bye bye. Thanks.